Welcome. I just wanted to go over some quick AI examples on just basically how you can think of pretty much running an AI agent, tracing, and what it just generally looks like. So for this example, I'm going to be using the Versail AI SDK. There's a few reasons why. I like this framework more than others. It's not too comprehensive. It doesn't do too much for you, but it does allow you to connect to multiple different model providers with ease. And I really like that. And it also has structured outputs. It includes streaming, and it also helps with very good generative UI interfaces. We're not really going to go into the generative UI interfaces today, but we'll just look at a quick examples on a few AI calls or just LLM calls that you can use with the Versail SDK. We'll also be looking at how we're actually doing logging with the Langfuse and how that looks and what you can do to trace things. This is just a quick look at how this works. So let's just jump in. So we're going to start with a very basic one here. We're going to just make an agent. We're going to use ChatGPT 4.0 for this one. And we're going to just say, invent a new holiday, describe its traditions. And you can see here, we've got this experimental telemetry flag ticked. This is just showing that we're going to use a open telemetry. What's it called? It's OTPL. It's OTL. Just want to make sure I'm getting this right. Yeah, it's open telemetry protocols. That's it. So we're just basically going to be using the Open Telemetry protocols, which allows us to just log a lot of the LM applications. Open Telemetry is a widely used framework. There's a lot of different open source platforms that allows you to capture this data. So anyway, so we're just setting the tag here as true, and we're enabling it. And you'll see here, we've got this function ID that's just like a tag, and then we've got some custom metadata here. We can even add a different thing. We can even have our own tag, and we could just say, this is a holiday maker. Cool, sweet. All right, so I'm going to be using Bun for this, so I'm just going to use the Bun run. And Bun's just a very useful platform, useful framework, I should say, just to quickly run TypeScript applications. If you guys didn't know, in the past, it was a bit tedious to run TypeScript, but Bun makes this a lot more simpler. There's also Dino that came out recently that also makes this a lot easier, and even React and, well, even Node itself is up. Done a few updates to try and make this whole experience a lot easier. So I do see this going forward. So let's just quickly run this one. So we're just going to go package. I don't know what happened there. In packages, and then we're going to go to examples, I believe, and then it's basic log. All right, so it's just going to run. Shouldn't take too long, and it should execute. All right, that took a lot longer than I expected, but maybe it was just doing some connection to the OpenAI API, and just took some time. So you can see the holiday name was Harmony Day. The date is the 1st of Saturday of April. Purpose, Harmony Day is a global celebration dedicated to prompting peace, unity. So you can see it made up a completely random holiday. Nothing too crazy there. But if we go to Langfuse now, we can go to traces here, and we can see that run that just happened. We can also see how long it took 1.8 seconds to finish. We can see the total cost in this case, very simple. And we can see the observational things. And we can have tags here if we actually define that a bit better. But if we go in, we can see what model was used. So I didn't actually log that information, so it doesn't show here, I believe. Did I log that information? It's got the cost. So it definitely should know it is ChatGPT. I'm just not seeing it on the tags here. Why is that? Does it not show on the tags? No. So I just didn't add the tag, but it knows the model ran. But anyway, so you can see here, this is the prompt to invent a new holiday and its descriptions and its traditions. And then we've got the output and the metadata here. And you can see we've got our tag that we inserted earlier. And we can even go to a timeline to see which part was working. This is not too crazy for just a simple LM call, but you'll see where this gets a bit more interesting. All right, so we're going to go to another example now. We're going to go to one that has a tool call and can maybe take multiple steps to complete a function. So let's just jump into what that look like. All right, so just looking here, this is going to be an agent that will solve mathematical problems and use a tool to help it actually calculate the maths. We know LMs are terrible at actually calculating numbers themselves, so having a tool that it can actually ask it to do calculations for itself is great. So let's have a look. So here's our create calculator tool. So you can see we're giving it a description. It's a tool to evaluate mathematical expressions and what the expression is. And then we go to console inside time. The tool call is what's the expression, and then we've got the result, and it returns the result. And then we've got to create answer to this one. I'm just using because This is the Versail AI SDK. So just to go into why I'm doing this quick. So if we go to the multi-step, where is it? It's a tool calling. It does this have the multi-step? Yeah. So in the multi-step, it pretty much you can give it a max amount of tool like steps it can go through before it X's out. So you'll probably see that with some coding agents, they'll give it a max step. So you're like, here's your coding tools, and you can iterate constantly with it. But what happens is sometimes you can ask for a structured options where you force the tool call is required. So it's tool choice here, and you got auto and required and none. But if you make it required, it's got a weird thing in the library that you would think if you've done the execution of the calculation, you will now give me the result. No, because if required is ticked as true, it always use a tool regardless of what's coming through, and it will only end with a tool call. So in this code, we've got this create answer tool. So if we do check that as true, it can answer back in this format, which is a structured approach. It tells us the calculation and the reasoning, the answer, and the explanation. So at the moment, you can see the tool is auto. So we'll run both cases just to show the differences. And we can see the tool choice that we've added is from tools, and we're defining our tool calls here, create calculation and create answer tool. So we're going to run that. So we're just going to go to the multi-step. And we're going to run that and just see the output that comes out. All right, so we can see it hit the tool call multiple times. So it did a few different calculations, and it then produced the answer here, $91,020. And then it gives the explanation, and this is the full result. Now, what's nice is we can go back to line views, and we can go and actually look at the tracing for that. And there we go. Our calculate step function came in. We used X amount of tokens. It took 3.6 seconds. We can jump into that, see what actually went wrong, what happened. You can see he has all our different specs. We can see we've got a span in our tool calls to see what was going on. And then we've got our last generated response because it actually generated the request back out. So let's just have a look. And we can just jump between what actually happened. So we got the expression, the output. We can just see what happened, and then you can see the output. So the answer quite reasonable. All right, so let's try just setting this to required. All right, and now we'll try run it and see how different the output would be. And we can just go. So before I run this again, just look at what was the output in the end. So it pretty much gave us our answer like this. This one actually did use the final answering tool. So let me actually just do a quick fix here, and let's just make this auto. And I think, all right, so we're going to run that again, just so that's the basic logo. The multi-step, there we go. Let's run that again. I'm going to jump through all the three calculations, and hopefully it'll give us a different response this time. And here we give the result, breaks down the steps. I think because in the prompt, we actually tell it, never assume you can do the calculations, always get the number, use a tool to provide the answer, and we also tell it to reason step by step. All right, and therefore it gives the profit like that. So let's take the format and we just jump back to our tracing again. Oh, that's coming through. Oh, that's interesting. I don't know. I must have done something wrong. Oh no, this is the output from the last one. This was the generation I was waiting for. It just took a bit of time to reflect, but we can now jump through and just trace what's going on. Other thing to note I haven't really mentioned, but you'll see we're using this SDK start, and then at the end here we're doing this await function, or this await SDK shutdown. Because what happens is we're using Node.js, and we're not going to put this on a Lambda function, and the result will actually be done before we send it to the logging, and we want everything to finish and do the request to the logging before it actually shuts down. So we just tell it, hey, wait for the SDK to shut down. There's also Vercel await, and that's also a good function. I'm not really using it in this example, but I think that's actually a better one to use. So, anyway, I hope this just gave you a quick idea on just some of the things you should look at. We can do multiple function calls on this. So in this one, we did the calculation and then the answer, and it jumped through 4 different